Alright, so, this is the assignment that we've got cooking up here. You'll notice that this assignment is pretty explicit about what it wants, and you have to pay attention to this more than anything else. Up at the top here is how I'm going to turn off, how I'm going to give you points. Really, I want to see that you created it correctly. So it has to look like a decent PowerPoint file. Like it has to have the master slide and all that sort of stuff. And then I'm going to look at the content. Notice the content is even less, is worth less to me than knowing that you did it right. So part of this is following directions. Lucky for you, the directions are very explicit. They basically tell you what the 7 slides have to be. They tell you you need to show your ERDs. Now this is a situation where I'm your customer. I'm playing the role of your customer. And again, I need to know that you understand what you're talking about when it comes to database design. If I were to give a presentation to management for a proposal, I would never include the technical stuff. I have made presentations to venture capitalists, and they always bring their chief nerd along with them, someone who's on their advisory board, who's usually a PhD and has all sorts of patents and has been a successful entrepreneur in their own right, and they will want to know exactly the technical details. You'd better be able to dance on your feet to give them all of the technical details. So typically your presentation has 2 parts. You do an elevator pitch to the guy with the money, and then you do a detailed technical review with the nerd. And I say that with the most utter respect for both those guys. So you convince Moneybags, and if you get through Moneybags, then you better be able to sing and dance for the nerd. In this presentation, we want both. We want you to give me the pitch, and they list it as an agenda here, but I really want your first slide. If I don't look at anything else, I want your first slide to sell me on the idea. I don't want a boring, this is what we're going to cover in this presentation. I want you to be able to make that sale in the first thing. Your last slide kind of does the same thing. I want to see, this is what I'm offering here, and this is why you're going to say yes. So what's the answer? It's yes. Let's get a commitment. Who knows what an elevator pitch is? An elevator pitch? Okay, so an elevator pitch is, the concept is you're going to Megacorp to do your pitch. And after years of work, you've gotten a 15-minute opportunity to talk to the CEO of Megacorp. You hit the elevator button, and you get in the elevator, and boom, who's standing next to you in the elevator but the CEO of Megacorp? And she turns to you and she says, hey, you're the guy who's going to make that presentation today. I got to cancel on you, but if you can pitch me on your concept by the time we make it to the 30th floor, maybe we can do business. Okay, so you've got 10 seconds at best. You've got maybe 3 sentences. And the first one is the only one that really counts, because if you lose her at the first one, she's not going to listen to the second one or the third one. So that's the concept. You've always got to have an elevator pitch ready. If you want something, if you want to accomplish something, whether it's a job, whether it's, I'm pitching companies, and I've got to, when I walk up to someone, I've got to have that elevator pitch ready. And just like we mentioned earlier, the first sentence always includes, I understand you, and I've got the perfect solution for you, and you can trust me. And you got to somehow get that all into that first sentence without boring a person. Because then you watch their body language and you watch their reaction. And if they're happy with you, if they want you to keep talking, then you can go into depth. And it's this constant reveal. Everything you say always has to matter, and if they stop listening, it always has to give the whole story. If that works, they'll ask for more information. You've got to do that again. You've got to give them a little more information, a little more depth, sell them on that idea. If they like that, they'll ask to see your deck. They call this a PowerPoint deck. They'll say, email me your deck. And you got to send it to them. Or depending on the people you're pitching, they may hate to see PowerPoint. They don't want to see the PowerPoint deck. They want to see your demo. They'll ask you, I want the next thing. I'm willing to listen. Give me your next bit of information. In this situation, they'll ask for your deck. At an EC thing, they'll ask for your deck. If the deck works, and usually you only have that first slide or else they'll walk out on it. These guys are busy, and they've got 100 people waiting to see them after you're done. If that first slide sells them, they'll sit through a few more slides, and then they'll say either yes or no, and then they hand you over to the technical people, and you get tortured to death so that they can trust you. In our simple little experiment, you've got to kind of help put that whole thing in the deck. But that first slide has to really punch it up, and the last slide has to really punch it up. Okay.
Is deck declaration, what does deck stand for?
It's like a deck of cards. It's a deck of slides. The one that we give you, the PowerPoint slide, is horrible. It's just a stinking horrible mess. It has a boring purpose slide. It has too many words. Now we are telling you, I want to see your tables. The way you're going to make me trust you is I have to know that you can design databases. And the way you're going to do that is you're going to show me your ERDs and maybe your schema. Okay, so this is a little artificial. If this were a real pitch to a real customer, I wouldn't care. I want to see your portfolio, sure. But I really want to talk to your previous customers. Here, you don't have any previous customers. Here, I want to know that you don't know databases. So show me your database design. Show me more about how the SDLC works, and then this, again, is it's a pretty good slide. I mean, they're telling you the benefit, they're telling you the cost, but they don't have an ask for it here. And like we talked about earlier, a $3,000 PC is better just jump through hoops. But they have a pretty good benefit statement. Right? It's too many words again. So anyway, see what you can do. Give it your best shot. And like most things, don't spend too much time on it. Let's talk about the SDLC. Oh yeah, my last little personal story about pitching. I had this program I was working on. The thing, after I had gotten the German guy to agree with me that he would get in line, then I needed to get funding. It was not a big program. It was only $500,000 in terms of licensing and a staff of 7 people. It was not a big project. But I had to get approval at the CEO level. The guy who signed off on the budget was the CEO of the company. This was Tektronix, which at the time was a fairly large company. It was a small enough project that he didn't want to be bothered. He didn't want to be bothered. It was too small for him. He didn't say this to my face, but I had networked with enough people that I knew that I was never going to get an appointment with the CEO. It just wasn't that big a deal. So we networked furiously, and we found the guy. Turns out the CEO trusts a particular VP. And if it was okay with that VP, it was okay with the CEO. And I heard this through the grapevine. And my VP, whom I had gotten on board 6 months earlier, this was like year 3 of a project that wasn't funded. Tech moved really slowly at the time. The VP and I worked on this PowerPoint deck for literally 2 weeks. It was a 3-slide PowerPoint deck. I had 3 slides in the middle of a larger presentation that was part of his monthly presentation. And I wasn't allowed to say anything. This was my project. I was the project leader. I was the manager. I wasn't allowed to say anything. In fact, I wasn't allowed to leave the meeting. But it went well. And then he said, so-and-so wants a meeting where he wants to hear the pitch. And I said, great. So we lined it up, and it was so weird. It was the weirdest situation I've ever been in, because we're sitting in a meeting, and the VP says to my VP, so how are your kids? And the VP says, they're doing well. He's at OSU. Oh, OSU is a great idea. And we're kind of sitting there, and I'm thinking, what are we doing here? And then the deciding VP says, so is this okay? Is this a good idea? And my VP says, yeah, I think so. And the other VP says, okay. And we're done. And there were 20 people in that room to listen to that conversation. And we were done. And I had been in a similar meeting in Japan a year earlier. And in Japan, the culture is very cool, and the meetings are very cool. the guy who's making the decision, well, first of all, in Japan, this is way off topic, but in Japan, the meeting room was like this, the door was here, the table was like this. There were 30 people in the room. Where is the power seat in that table? Where is the most important person's?
Middle of the
In
table.
the middle.
Where?
Middle of the table with his back to the wall.
Right here. He was there. He looked asleep. He was like this during the entire meeting. Now, I was told that I had gone through cultural training with Berlitz and a whole bunch of other people. I was told that that was a sign of respect, that they close their eyes when they are listening carefully to you. And I had seen that in other people. And he never snored. So I had the feeling that he was awake through the whole presentation. But clearly, my PowerPoint slide didn't make it squat. A bit of difference. The number 2 guy, the number 3 guy, the number 4 guy, people I had already talked to, all technologists. Well, this guy was business. Where do you think I sat at this table? The only Caucasian in the room.
At the end.
Over here. In
No,
fact, I
the other
sat right here. Nearest to the door, back to the door, neck exposed, the lowest of the low position in that entire room. It was so cool. I knew exactly where I stood. And my being there didn't matter. It was a formality. It was an important formality, but it wasn't my decision. The thing was, I had made my case to these men, and they were all men. And they had all agreed previous to this that it was a good idea. They all had a benefit coming out of it. I had demonstrated that I understood their particular problem. Each one of them had different problems. Each one of them had different concerns. But the meeting, where we all sat down and decided, this guy basically said, was pure formality. And America is the same way. You have to do your legwork. Having a good PowerPoint presentation in the real world is just one of the many pieces you have to have in order to succeed. You have to convince a lot of people, and you have to do your homework. Okay, shift gears. Let's talk about the system design life cycle. This is a phase gate approach. This is a repetition of what we covered in 122, or 120 rather. There are multiple phases, and there's a gate in between each one. You don't get to go from one stage to the next unless you've met all the criteria for the previous stage. At any stage, someone can look at your plan and say, no, this isn't working. We got to shut this puppy down. We spent enough money. This is a bad idea. It's a wonderful way to work. So for those of you who were in 121, the first phase was called plan. What's the next phase? Anyone remember?
Design.
Nope, that's later. Analyze. So the first thing you do is you think about, what do I have to do this project? Where are all the pieces? I don't even know what I'm doing yet. But I know how projects work. I know I'm going to need people. I know I'm going to need time. I know I'm going to need money. The iron triangle. You need resources. You need time. And you result in quality. You can turn out good stuff if you've got enough people and enough time. Enough money. Money is the most expensive thing in any project is the people. Especially good people. They're not cheap. And they always say, you know, I can have it for you quick, I can have it for you cheap, or I can have it for you good. Pick any two. You're constantly trading these off. Anyway, you don't know how much of those you're going to need. You don't know how many people you need. You don't know how many resources you need. You don't know how long it's going to take. You don't even know what they want yet. But every project has that same kind of framework. I know I'm going to need these pieces, so let's start lining them up. A good project manager, has anyone done project management before? A good project manager is constantly thinking, who can I get for my next project? Where's the money going to come from? How do I work the system? How do I work this organization to get people in the right place at the right time? This is not the last time you will plan. You'll come back and you'll plan over and over again. So the first step is planning. The second step is analysis. analysis. That's what we talked about last time. What does this business do? What are we trying, what's the problem here? Who are the people? What do they want? What roles are involved here? What are the requirements? You go through that process, you understand, you listen to people, you talk to people, you follow up, you come up with requirements. Business rules. I want an inventory system. I'm tracking widgets. Widgets are like this. Okay? A lot of work goes here. A lot of work goes here. Sometimes you'll prototype stuff. You'll actually write code. You'll prototype in Scratch environments. You'll throw it away. You do a lot of work to make sure things work. I'm describing what's traditionally called a waterfall model. We don't use waterfall models anymore. But we're going to talk about the phases as if we're going to go through it once. And then we'll talk about how it's actually used. This is where you understand the problem. This is called problem space. You stay in the problem space. It's really tempting for you to jump ahead and say, oh, you need an access database. Maybe not. It may be that what they want can be solved some other way. And especially if you do business analysis, if you look at if they're interested in making money, you can use this technique on any kind of system, but if they're interested in making money, at this point you can get a pretty good look at the market. And some people, there's always a threshold for return on investment. So if you say, well, the market for this is there are 30 people on the planet who will buy this. And we know their names. That's your analysis, that's your market analysis. Does it necessarily stop there? No. I mean, if you're selling jumbo jets, customized jumbo jets, or 500-foot mega yachts, it's fine that 30 people on the planet will buy your mega yachts, as long as they're willing to pay what you want. Now, if you're selling iPhone apps and only 30 people on the planet want that iPhone app, go home. Think up something else. Okay? This stage is where you decide, what are we trying to accomplish? And one of those accomplishments is always, how much money do we need to make? And it's usually not a lot of money. You know, how do we cover, no one thinks, I'm going to corner the market on iPhone apps. You always think, what market segment do I want? If it's an internal project, like I was working an internal project, an IT project, it's like, what incremental improvement can I make that is a significant return on investment? Sure, we spent $500,000 on that system. We took 3 years of 7 people's time. We saved $1 million a year. So in the end, the thing saved the company $2.5 million in its first 3 years, paid for itself in its first year. It's been paying off for them ever since. So sometimes what you're going to get out of it isn't necessarily profit. Sometimes it's cost avoidance. If you're doing a security project, if you're going to come in and say, we're going to tighten up the security on this IT network, you're not really saving any money. You got to spend money, but you're securing the environment. You're preserving capital. You're making the world better for that company. Any case, first analysis. Stay in the problem space. What comes next? Design. This is the solution. Now, in terms of database design, this is your entities, your attributes, your ERDs, your tables, all that sort of stuff. You're designing it here. You may even start thinking about what database engine am I going to do on this. If your requirement is, we're Facebook, we have 500 million people online at any particular time, that's a clear requirement. You know your design is not going to include a single access database somewhere. Your design has to include scalability because you have really significant scalability requirements. If you're building an iPhone app, well, the aspect of what platform you're using is already taken care of. I've got to run on an iPhone. Even then, you think to yourself, am I going to support old iPhones, or am I going to only do the most recent ones? What about Android? Blah, blah, blah. Here, it's how does it work? So, ERDs, tables, actually, I'm wrong, ERDs go here. So, tables, relationships, queries, forms, reports. In our little world of database design, how would I actually build this? Notice I said, how would I build it? Because the next phase is implement. In some places you can see this called construction. This is where you actually plug the stuff into the database engine and you build it. This is when you build it. You build. Now this is kind of disingenuous because I told you earlier, you're prototyping way in the beginning. So sometimes, especially if you're designing a big database that's running on an enterprise scale, you'll use Access itself as a prototyping environment. All you'll use, you'll get one of your better coders to sit down with somebody who can really code quickly, and you'll have them write something up and just flange it out and show people. Just as a way of saying, is this the right thing to build? Is this the problem? So oftentimes you'll be doing construction already. What I mean by this phase is you're building it for real. You're building it for deployment. So I did a website design for a customer. We did wireframes here. I sketched, this is what the website's going to look like. Really low fidelity. Here, I designed it, we did it in HTML and CSS, and it ran, but it wasn't connected up to a database. So I had JavaScript that made it look like it was connected up to a database so that people could see, yes, that's the form I want to see, that's the report I want to see, but I didn't actually go through and actually build it on the website. Now I'm in this phase with these people, and we're actually deploying it onto Roku, and we're building the Ruby on Rails code behind it. As I do that, they get to see what they're actually buying, and they say, no, that's not what I asked for. We'll talk about iterations here in a minute. So in the building or the implement stuff, we're building the deployable solution. Deploy. Who can define what deployment means? What does deployment mean? Sure.
Start using it? Or,
Yes.
or actually get it ready to be, or train people. And
something that will run under load. That if you're going to support 50,000 users, this is the system that you build that will run and will support 50,000 users. And then you actually go ahead and deploy it. You put it out on the net. This is where you start to see alpha testing, beta testing, and launch. Those of you who have launched software before know that all those sorts of activities, at this point you've actually got code, you know how it works, it's running on your prototype systems. At this point you start building it up so that it runs, you're exercising it so that the bugs are out of it, you're scaling it up so that it can be used by a lot of people. Deploying an IT system is a really fun job. It's a really fun job. It is nerve-wracking. And it's amazing how many IT deployments fail. Where, well, just last year, First Tech Credit Union tried to roll out a new website with all sorts of cool features, and it failed. And they had to roll it back, and they had to send out a letter to all of their shareholders saying, sorry, we'll try again next year. Major loss of face. If you're in an IT environment, failing on a deployment, oh man, gets you fired. So you have to be real careful. At this point, you are launched. You are in the field. People are using your system. So at that point, what do you have to do? You have to support them. Sometimes you see support called maintenance, but that is a low-grade way of thinking about it. A lot of people think, especially a lot of young engineers, think you're done when you're at this stage. Older engineers think of it as being done here. These days, most people think of, business people at least think of, this is where the whole thing matters. This is where your customers are using your product. And they, remember I showed you that Photo Jojo site the other day? That Photo Jojo site? That is when I really got the first time to see that product. I ordered one of their products. I ordered one of their little lenses. It came with one little thing. I thought, oh, I'm going to break this. And I sent them an email and I said, can I have another one of those? I'm going to break it. Within 20 minutes, I got an email back from a guy named Jeremy who said, sure, but you know, we can't, can you send us $1 for postage? I thought, oh man, I don't want to send him $1 just because of the hassle. And he said, click here and send me $1. And click with PayPal, I sent him $1. I got the dang thing in the mail the next day. I'm talking to you about this experience. Support is where customers are made. Support is where people fall in love with you as a company. And they tell other people about you. So there's a cost side to support. That's where, yeah, everybody's been on phones, you know, with people that says it doesn't work. Everybody's worked with an IT department that doesn't seem to want to help, and support is just a nasty afterthought for their management. But you guys need to think in terms of support is when you make customers. Support is when things happen that keep people coming back. And the real cool thing is now you're actually in market with a bunch of customers. Now they are going to tell you what they think of your product. Oh, that is the best time ever. That is the best time ever. Especially the jerks who will blog about your product and tell the world exactly what's wrong with it. Those are the people who are pointing the way to the future for you. And that's when the whole thing comes back around and you analyze what are they telling you. And you say, okay, now I know what version 2 is going to be. Because half of our customers want to see this new feature. We heard it from them straight through the website. Half of them want this new feature. Well, let's go build that feature. Let's keep them happy. Let's sell them an upgrade. Now I said it was a phased gate. Those are the phases. Let's talk about the gates. Well, first of all, let's talk about iteration versus waterfall. Now you might think that you'd start with the plan and then you'd execute the plan. That never happens. You start out, we write fiction in our first plans. We say, oh, it's only going to cost this amount of money, it's only going to take this many people, and it's going to be done in that time period. That is never true in software. It's never true. And yet we always tell ourselves. The only time I've seen that work is when the same team of people did the same product over and over again. They could predict with frightening accuracy how much the next product would cost, when it would be done, and how much effort it would take. This was the Logic Analyzer team at Tektronix. Some of those guys had been building logic analyzers for 30 years. And when they hired people who they knew they could work with. It was one of the best teams I've ever seen. Cohesive, self-supporting, they all liked each other, all really smart. And when they came out and said, we're going to turn out a new logic analyzer, the neat thing about Tektronix, a logic analyzer is a machine that shows you digital signals. It's a really cool machine. They would go over to Intel. Tektronix had a long partnership with Intel. Usually either Intel would show up on Tektronix's door and say, we're doing a new microprocessor. It has to go twice as fast. We need a logic analyzer that goes 4 times as fast. And Tektronix would say, yes, no problem. So if the Intel chip was going at 3 gigahertz, the Tektronix logic analyzer had to go at 10 gigahertz. Had to go a lot faster for various technical reasons. So the customer, they had the same customer for 20 or 30 years. They had a lot of knowns. You know, there's knowns and there's unknowns. They had very little risk because they had the same people, they were building the same kind of product, they had the same customer, and they were experts. They were the world's experts in this. So when they said it was going to take 18 months and we're going to take a team of 10 people and it's going to cost $20 million, boom, it came in on time every time. It's the only place I've ever seen it. The other place I've seen it is when we went to the moon, where someone said we're going to do it in 10 years, or was it 9.5 years?
By the end of the decade.
By the end of the decade. and we're gonna do it, and bring everybody home safe. And that's the only project I've ever seen of that scale that came in on time. So many other projects, you learn what it's gonna take, and there's flexibility. Some projects, they get all the way to here and they fail. I think the FAA has tried to replace their computer system at least once, and they never got to this stage. For some reason, we are unable to deploy a new FAA system. Well, we're gonna have trouble there if we don't already have trouble. So what you have to do is do this over and over again. So instead of a waterfall, where you go from the beginning to the end, we don't do that anymore. We use iterations, iterative. That means we repeat. We go around this loop where we do plan, analyze, design, build, support, and we go around the loop again. We do it really quick. Most projects I've worked on over the years were 18 to 3-year projects. I tended to work on fairly small things, so there were 7 to 20 people on it. If the projects where they expected to do this for 6 months, and then do this for 6 months, and then do this, they'll fail. So these days, people do this in what's called an agile or iterative manner. And this whole sequence, at least from here to here, is between 2 to 4 weeks. 2 to 4 weeks. So in order to do that, we have to bite off little tiny bits of functionality. Okay? So I've got a website. What's my first iteration? Well, let's just get the thing to serve up a page. Just one page. Okay, how do I do that? Well, I'll build it up. Oh, now I get a website. Ah, it's serving a page. I'm done. What's the next thing? You go back over and you say, well, let's have that page have one form on it. Let's have it talk to a database. Okay, well, how do I do that? Okay, what am I going to do? Fine. Look, I got a database running. Boom. Now I've got my form. Boom. I'm done. Yay. We look at it. We hand it to some customer. Customer says, that's what I'm looking for. We go around the loop again. These days, what you're doing is you're trying to minimize the amount of risk. You're trying to minimize the uncertainty. So you do it over and over and over again as fast as you can. The project I'm on with this client, our iterations are 2 weeks long. The problem with projects is they can go off into the weeds, and somebody is in trouble. Some developer doesn't know what they're doing, or they bit off more than they can chew. A lot of, especially in research projects, you don't even know what the technology is when you're starting out. And some things you just can't do. Like when they did the Newton, the Apple Newton the first time, they didn't quite get the handwriting recognition correct. They did a lot better than anyone had done before. But they made it out, and it wasn't quite good enough. They've done that over again. Anyone here use a Palm Pilot? An old technology. They bit off the problem a different way. They said, well, we won't recognize everybody's handwriting. We'll recognize this particular kind of handwriting. It'll work much better. These days, people don't even do that anymore because now they've got voice recognition. You were telling me about Dragon Naturally Speaking. Dragon Naturally Speaking is a voice recognition software that is just amazing. It's wonderful. The technology is now built into the Apple iPhone 4S. I don't know if they licensed Dragon, but voice recognition is now a viable product. I dictated a memo to my boss in the car over here by talking to my phone. So, not only are they iterating inside that particular project, but the entire industry is iterating on this concept. I want to be able to talk to my phone. I want to be able to, when I'm standing in a Starbucks, I want to take notes, and I want to get this thing in a pack of playing card size package. And we have tried over and over again over the last 20 years. We're finally getting it right. So think in terms of cycles. Don't try and do everything at once. Do something simple. But the takeaway here is you always should plan first. Think about, what do I need to have? You know, if you're building a car, you think, what tools do I need? Oh, I'm going to need a lift. Oh, I'm going to need a garage. Then analyze the problem. It is so easy to code these days that people jump to coding before they even understand what they're coding. Don't do that. think about it first. Write something down, draw some pictures, do some analysis. If you want to code something, code away, but throw that code away. And if you work for a manager that says, oh wait, you've written code? Ship it. Don't tell them. If you're unfortunate enough to work for someone like that, just don't tell them you've coded it up. When you design it before you code. Think about what you're trying to build before you build it. You would never think, oh, I'm going to build a house from scratch. I'm going to buy some wood and I'm going to go start building it. No one would ever do that. Although, I'm sure people have tried. No one who expects to make money or to live in a resulting house would ever do that. I mean, you always start. And you start in terms way back here. Think what's my ideal house? Do I want to live up high or do I want to live in the woods? Do I want to have sun in the morning or do I want to have sun in the afternoon? Do I want to live close to people because I like the nightlife, or do I want to live out in the woods so that I can have my privacy? You've got to understand your goals. Then you get to write the blueprints. Sometimes you build your house out of cardboard or that foam core stuff. A lot of architects will work there. These days we use all sorts of visualization. Then finally you build the thing. No one would ever build a house without these steps. Don't build software without these steps either. I know it's tempting. And the guys like Microsoft that sell you coding tools want you to think that you can code right from the beginning. And in fact, what's really despicable is they'll say, click here, and I'll pre-populate your entire software project. And they'll dump a whole bunch of code on you, and it looks and it feels like an application. In fact, Ruby on Rails does this. It's called scaffold. You click here, you enter this command, and all of a sudden you've got something that looks like software. And there's a lot of code there. But you have no idea whether it's doing the right thing. And the guy who made that wizard certainly has. So think, design, then build, and then most of all, give it to customers. Show it to people as fast as you can, and give them the chance to tell you that you are wrong. Company called Flickr, F-L-I-C-K-R.
Yep.
When they went out, they were not building a photo site. They were building like a dating site or something like that. And the photo aspect of it was just a tiny bit. They handed it out to customers and they nearly died. People said, we don't want this, but you know those photos are cool. I'll upload photos there. They were very successful as a photo site. They have found a niche now among semi-professional photographers, people who love photography. A lot of it's being replaced by Facebook. I think Facebook is storing more photos. The essential thing though is they went through and they said, well, people need a dating site or whatever. And they built a dating site and their customers said, no, we'll use it for photos, but we'll find dates somewhere else. Now they've iterated a number of times. They have a very cool photo site. I think Facebook's going to eat their lunch if they're not careful. That's the way of the world. Okay, so that's the phases. We talked about, you go through the phases over and over, and last thing is the gates. At each one of these gates, you have to make the decision, especially if you're in a corporation, you have to make the decision, and I'm drawing these little decision diamonds. You have to make the decision, should we continue? And it's really hard. It's really hard to stop something. Because especially you've been talking to people who really need help, and they really want this system. They want something to help make their lives easier. And sometimes you just have to tell them how we can't build what you want. Sometimes you don't even get out of the gate. Sometimes people say, you know, I'm sorry, we're in a recession. In fact, a guy said this to me. I said, can we start? First year of my project. Can we start? He says, sure. Name 3 people that I lay off to get you your money. Kind of a jerk to say it that way, but that was the case. We had no money for anything. And I was not going to lay off any one of my people or any one of my peers, and I certainly wasn't going to take a bullet for that company. So we waited to the end of that. It was the 2001 recession. All page has an exit criteria. How do I know when I'm done? Well, I've got a good set of business rules that my customers signed off on. I've got a good set of ERDs that my customers signed off on. I've got a good set of requirements that people like. And again, these may not be, you don't need a big document. Sometimes you get a big document. You don't need a big document. Sometimes it's like, I need a website that serves up one page. And you're clear on that. You move forward. You've got to be testing here. You've got to be testing at every stage. The type of tests are different. Sometimes early on, it's just a smell test. Does this make sense to you? At this point, you're looking at design. Sometimes you've got code. You've got a prototype running. You can actually write code with it. At this point, you've got automated testing. Automated testing. Where you've written software that is running against your software and load testing and trying all sorts of things out. Sometimes those things fail. Sometimes you run out of time, and the market eats your lunch, drinks your milkshake, and the company has to shut it down. If you are really, really unlucky, you get to here. I was doing the world's first color electrostatic plotter. I got a patent. It was a big printer. It's the size of that table. It's actually the size of the printer, the size of this table. It's a long time ago. It's this tall. It was this big. And it was electrostatic, which means we used thousands of little wires and we sprayed electrical charge on this paper. And at a microscopic level, charges, it's like fireworks. We actually can see it. We had cool microscopes. You slap this charge down on this paper, and then you run the paper through a bath of kerosene that has carbon particles suspended. And the carbon particles stick to where the charge is. And it comes up out of the bath, and all of a sudden it's printed. And the wonks in the chemical department figured out how to make cyan, magenta, yellow inks out of this stuff. And I was the guy who wrote the software to manage the internals of this thing. And it was so cool, and we went to show after show, and everyone was like, wow, that was so cool. And the thing about it was that we could make plots that were 200 feet long. We could print out something that was, the rolls of paper were 200 feet. And there's one industry on the planet that needs plots that big. And it's the geophysical exploration people. These are the people who lay down dynamite charges and put sonic sensors in this big chain along the surface of the earth. And they fire off those explosives. And the sound pulse goes down into the ground, and then it gets picked up by these little sensors. And it creates this huge plot. And if you know what you're looking for, you plot that thing out and you go, oh, there's oil right there. You can see it. You can see these pools of oil under the earth. A company we were working for was called Schlumberger, the #1 oil exploration company on the planet. And they had basically told us, if you can make us a color printer that can print out a 200-foot piece of paper, we'll buy it. And we got to here. We got to here. And the bottom dropped out of the oil market. It was yet another oil recession. And a friend of mine in Texas at that time lost his house. A whole bunch of people went out of work in the oil business. And Schlumberger said, no, never mind. We don't need this. Nobody's going to be drilling heavy wells for another year. So thanks, but no thanks. And the company went right off the deep end. Luckily for us, Schlumberger bought us because they wanted the patents, because they figured in 2 or 3 years they were going to need a printer. But boy, we laid off everybody. I made it through 7 layoffs. Got caught in the 8. But we made a really cool product that our customer wanted. And through no fault of anybody's own, we hit a recession, and that damn thing never sold one. We never sold one. And you might think to yourself, a smarter company would have seen that recession coming. Or a nicer customer would have told us, oh, you know, our won't say 6 months out, we're probably not going to want to buy that. We didn't know. So anyway, it is better to stop a project earlier, because you spend more and more money as you go on. We had tooled up, we had a factory, we had all sorts of stuff in place. We had spent millions of dollars ready to make that printer. kill the product here, and you decide, really, no one wants that, you're only out a couple of months at a time in some people's work, you kill it back here, you're letting people watch. So that's the SDLC. So when you guys give me a PowerPoint presentation, you're going to say, well, this is the table we want you to, this is what we think you need, this is the table I'm going to build, I'm going to put it in Access or whatever database you choose, I'm going to deploy it like this, and then I'm going to make you so happy as my customer that you will come back and you'll give me more business. What do you say? It's only $5,000. Better not be $5,000. What do you say? Give me a Sarah. That's it. Yeah.
Are we presenting in class or just turning it in?
Do you want to present in class?
No?
No, in later classes, you'll have a chance to actually do real stuff. This is, I think, going to be fun. Any other questions about the PowerPoint presentation?
Do you have an alternative site that avoid using PowerPoint?
Say it again? Is there any way to avoid
I was
PowerPoint?
halfway being as far as.
Not that you roll with it.
I don't.
No, I can't.
I don't do these things. I literally do videos in place of them. I made a documentary instead of doing a PowerPoint presentation. It was that bad.
There's only one PowerPoint presentation in this class. I don't like PowerPoint either. And unfortunately, it's next week.
So I skip it in this 20 minutes.
PowerPoint sucks. But too many employers depend on PowerPoint.
But part of the thing is like,
Thank you.